Hello everyone and welcome to Lab Manager's Product Spotlight webinar series. These webinars are designed to help attendees understand a specific proprietary service or technology and where and how it can be applied in an effort to help labs operate more efficiently. My name is Trevor Henderson, Technology Editor for Lab Manager, and I'll be moderating today's webinar, which will focus on choosing the right centrifuge for your lab. We like our webinars to be very interactive, so we encourage you to send us your questions at any point during the webinar. Many of you know the drill, but for those of us just joining us, please type your query in the question box, which is located at the bottom left-hand side of your screen. We'll try to address as many of these questions as possible during the question and answer session following the presentation. If we happen to run out of time, I will forward any unanswered questions to our presenter, and he can respond to you via email. Additional resources can be accessed through the resource widget located at the bottom of your screen. You may also move or resize any of the windows simply by grabbing them at the top or stretching them at the bottom right corner. At this time, you may need to move or minimize some of the open windows to see the live view. This webinar recording will be available early next week on Lab Manager's website. At the end of this webinar, we'll share that link with you, as well as the contact information for our speaker. At this time, I'd like to introduce our speaker who joins us today from Thermo Fisher Scientific. Dr. Daniel Hanle is the Commercial Manager for Floor Model Centrifuges at Thermo Fisher Scientific. In this role, Dan works closely to bring new and existing centrifuge products and technologies to scientists and lab managers, driving successful execution of product strategy, but more importantly, helping customers achieve their scientific goals quickly, reliably, and safely. Dan's background as a chemical engineer has prepared him for 25-plus years of experience in the centrifuge industry across various roles: engineering, sales, marketing, and business development. Thank you for joining us today, Dan.
Glad to be here. Thank you, Trevor. The first slide here, just my introduction slide. I hope everyone has got good ability to hear me, and we'll move on to just say a little bit about my company. First, our mission is to help our customers make the world healthier, cleaner, and safer. And one key way we do that in the centrifuge business where I work is to invest in new products based on our customers' needs, which are changing due to advances often in their research. And so this slide will quickly show you that we have a full product line from the littlest thing on the bench through bigger things, high performance on the bench, and then a full set of floor model centrifuges, which actually go up to large continuous flow systems and even blood bank centrifuges. So that's a little bit about us, but let's get on to the topic here. First thing about centrifuges. What is a centrifuge? We're referring to this. I just do a little basics for us here. First thing is that obviously there is a rotor inside a centrifuge. They're often interchangeable, in our case, essentially in every case, which runs on a motor. And for a refrigerated centrifuge, you're going to have that system as well. And finally, some electronics, a control board, which will also typically show you some information digitally on the front of the machine, which you use to control it. So those are sort of the basics of a centrifuge. We'll refer to some of that as we go forward. The other thing I want to start with as a type of introduction is that often we hear people talk about how fast their centrifuge goes, which is fine. It goes 10,000 RPM, 50,000. But to understand that the real issue, of course, is G-force. You take the radius of how fast the rotor is going, and that gives you this little formula here to give you into the G-force range. Because, of course, that's what's doing the work for your samples. And so you'll hear some of the folks who are in the centrifuge business talk a lot more about G-force than they do speed. So let me start by showing you this chart, where what we try to do is sort of give a little line here, left to right, from the smallest G-force all the way up to over 1 million Gs. And then below it in some color coding here, the idea is of what do you do, and what kind of work can you do at those various ranges. And you can see there are applications all the way across this spectrum, which is why we have different types of centrifuges. You can go all the way down to just harvesting cells at low G, where you don't want to damage the cells, so you're being as gentle as you can be, through some subcellular things in the 50,000 and upwards to 100,000 times G, and eventually you're basically trying to separate two molecules with G-force, and for that you do need those high Gs, DNA, RNA, You can show the nanoparticles here. So this is the way we see the centrifuge business. Typically, our customers come to us, they're looking for one or maybe two centrifuges, sometimes more, and they're looking in one of these specific areas. But this is the full spectrum, so we can all have that in our mind. Because in this chart, you're going to see I've turned that line vertical, and you can see from top down, how does it work? If you need the high G-forces or mid-range or even low, what are some options? And you'll notice that this chart has two halves to it. One is what we call floor model, and the other we call benchtop. And when you do get into the high G-force ranges, you do need these ultra centrifuges, we say micro, ultra, or supersede type centrifuges, to get those high Gs, especially if you want to spin any decent volume at all. Once you get down into the smaller G-force area, you have some options. You can go with a floor model or onto the benchtop. And actually, nowadays, the benchtops are getting much more powerful than they were, say, 10, 15 years ago. So if you haven't looked at a benchtop lately and you need to get a new one, I definitely would suggest you look into what the capability now is available on the benchtop. Of course, at some point, certainly with blood banking and things like that and large-scale bioprocessing, you will need the maximum volume you can get. And in that case, you would be moving to the lower left of this chart where you would have large capacity type of a floor model centrifuge. But let's start here. Let's talk about the place that we find is most important. I certainly do. Is that the end users are first usually encounter us by saying, this is what I want to spin, or this is what I want to do. So we like to talk about our centrifuges because they're the big things that are most obvious, and you look at them and the rotors that go in them. But we need to remind ourselves to start with what's going to be getting spun. So you can see there are some traditional things. Obviously, tubes and bottles are the most common thing. We can do culture flasks as well these days. Some new things are coming along. Of course, micro plates have been around for a while, but these multi-channel dishes, it seems like every time we turn around, there's a new application. So we're constantly looking for ways to spin those, not only just get them in a centrifuge and get them spun down, but to see how we can fit them in, maybe support them properly or some way to get even higher G-force. And at the bottom, you see bags, and obviously blood bags are the most common in that sense. So there are very many different types of, we'll call it vessels, but tubes and bottles type of things. And what we'll do in a centrifuge is typically try to get a centrifuge and a rotor to be as adaptable as possible with various adapters that you can put in there so that you don't end up buying a different rotor for every vessel. You can maybe get one rotor and then buy these different plastic adapters, as some of you are well aware, or even different buckets and things like that to make it as versatile as possible so that one purchase or one set of purchases can cover a wide variety of applications. Then, of course, there's the rotors themselves. And pretty much these days, it's either a fixed angle rotor you see there on the left or a swinging bucket on the right. And the typical thing is that the fixed angle rotors can get you the higher G-forces because of the way they're designed, and as a result tend to be more involved, say, in, as you see there, a floor model and the high end of the business. Having said that, it's amazing. There's always exceptions. And a little microfuge is actually a fixed angle rotor. That's the way those applications have been driven. So, here's a combination. Most of the floor model centrifuges that I get involved with actually do have both. They have fixed angle and swinging bucket, depending on the application. Usually swinging bucket applications are for gradient work and that type of thing. And so if people are getting into those type of things, we try to talk to them about how to manage their acquisition so they get what they need both in fixed or swinging bucket. But when you get down into the general purpose centrifuges you see on the right, it's much more common to have a large, very large nowadays, swinging bucket rotor with a lot of adapters. Now, it gives you an incredible amount of capability in a fairly small package and inexpensive to the extent that you can put one of these in a lab, say, and do many of the things that are needed and maybe not have to have maybe this and that other centrifuge. So again, if you're looking at buying new anytime soon, it may be that you have two centrifuges that are old. It could easily be these days with some of the innovations that have come on that you can put both of those aside and replace with just one unit, and maybe mix and match some of the rotor capabilities that would be available to you. Now, one specific thing that's been happening these last, I say, 10 or 15 years has been carbon fiber. This has come along into our industry like it has in most other industries, where carbon fiber replaces an engineered metal. Maybe it's aviation, cars. The big one I hear all the time now is bikes, bicycles. But of course, tennis rackets, golf clubs, it keeps going. And one of the key things to understand is that the reason that the carbon fiber comes in and replaces the metal is because of these things you see here. It's extremely strong. One thing very important for our laboratories is it's corrosion resistant. Almost any reagent we have in the labs these days will attack unprotected aluminum, which is usually the common metal we're replacing. So that's a positive, and that helps give us an extra life with these materials. They're very lightweight. That kind of goes right up front. Everyone knows that before you even have to tell them. It can, in that sense, require less power and put less wear and tear on your centrifuge to be spinning rotors that aren't as heavy. And of course, the main thing there is that it's for the user. Some of these big rotors we've had historically through the years have been over 40 pounds. You know, we just got used to it because that's the way it was and all we had available to us. Nowadays, rotors that used to be 40 pounds are under 20 pounds to over 50% reduction. And we put down here it will not stretch because it's interesting. Metal rotors also have another dynamic to them. We've pushed the performance of these centrifuges so much in these last years that we're pushing these metals so that it seems counterintuitive a little bit, but they do actually change shape a little bit at speed. And basically what that's doing is giving the most performance capable we can possibly put into the centrifuge in a metal rotor. But of course, on the other hand, that's giving it a fatigue life. It will fatigue over time. I like to say if you take a paper clip and you kind of bend it back and forth 3 or 4 times, it finally breaks. And that's considered a cycle life, let's say, of 3 or 4. And if you're really careful, maybe you can get it to go 5 times before it breaks, and now you've extended its cycle life. Metal rotors have cycle life too. They're measured in tens of thousands of cycles. But again, it's the same idea. Each time you run it, you're fatiguing it, and so it goes down the curve. And that's the key there. But one thing that's not on here that probably bears mentioning, because I run into this a lot, is people look at that and they say, yeah, carbon fiber, I know about that. I have my friend or somebody, or maybe even you, the user, has a carbon fiber bike. This is the one, like I said, I hear a lot. And the problem that they immediately tend to encounter in their own mind is it's going to cost me more. And that's the beauty of this. When these things have come forward through our organization, we've managed to do it in a way where the cost is essentially the same as the metal rotor. So I like to say, imagine a bike store with a carbon fiber bike in the front window, and the manager says that bike is the least expensive bike in my store. They would probably not sell any more metal bikes. And that's kind of what we've seen. It's certainly been a big change in our part of the industry, given the fraction of carbon fiber rotors overwhelming our metal rotors these days. So I want to mention that. That's sort of a big change in the last, say, 10, 15 years. It's been coming on strong. Now, here's one specific thing that happened. Once we started replacing metal, engineered metals with carbon fiber, we wanted to take advantage of all those things on the previous slide, but we also realized there might be some things we could do where we could take carbon fiber capability beyond anything you can even expect to do in metal. And this is probably the best example of that, where by designing the rotor properly, we can support these conical tube rotors, conical tubes, up to, as you see here, 26,000 Gs. And immediately, most of my customers I talk to immediately understand that means that you can do, if you see in the lower right there, you can change the way you do things. You can actually do all your work, including the centrifugation portion, without having to change tubes. Of course, that eliminates a bunch of things. It eliminates the chance to contaminate. It saves tubes, saves money, saves time. It saves on yield losses when you're moving material from one tube to another. And if you'll notice in the bottom right, that middle tube on the top, the old way, is a fairly expensive tube, and you typically don't throw that away, so you typically have to clean it and put it back in the drawer for next time. And the key thing we run into is people don't know how many times they've used that thing, and one of these days it's going to finally give up the ghost and have a failure. So in the bottom run, where you see the rotor, the tube going into the rotor, you're always running a brand new tube that's not been stressed before. So this is what we call the conical tube store, if you will. And the key thing here is to understand that carbon fiber not only has replaced metal in many cases to make it lighter and corrosion-free and these other issues, but it has also given us the ability to do things that we couldn't do before because of the physics of the metal rotors. And let's keep going into the centrifuge. So now we've talked about the tubes, we talked about the rotors. You remember up front I showed that sort of cartoon of what a centrifuge kind of is made up of. And here we're talking about refrigeration. This is so important, especially on the benchtop where there's an option to choose a refrigerated or what we might call a ventilated or a non-refrigerated centrifuge. And it really just depends on what the research is. Obviously, the key reason to go with a ventilated centrifuge is it's less expensive. It also tends to be smaller, and bench space is typically very much an issue in the lab. So that would push folks to think ventilated, and that's fine. What happens in ventilated is the centrifuge is designed with ports in it to suck in the room air and have that essentially cool, whip around inside the chamber, and then go out another direction, and essentially become a bit of a type of fans mechanism that pulls in ambient air and then cools the chamber because the rotor running in there at any type of speed is going to create heat and push that away. So typically, your samples can be in these air-cooled centrifuges, ventilated centrifuges, and never see much more than a 1 or 2 degree rise. And now there can be cases where people are running them very hard. Just as soon as they're done, they open it up, throw in some new samples, and go again. And when you have to watch that, because sometimes you'll see a temperature rise over time as the chamber tries to warm up, given that hard usage. But basically, they do that. Now, obviously, if you want to do anything other than ambient temperature, then you're going to need a refrigerated centrifuge. But the good news is these days, so many of these centrifuges have been doing this for so long that it's a well-established technology to be cooling chambers, cooling samples. But one thing to understand is it's a little different because now the chamber is going to be sealed. You don't want ambient air coming in there. It puts stress on your refrigeration system, may make it so you can't cool as far as you want to. So these are sealed, and if you look at the picture at the top with the lady there putting the cap on, you can almost see behind her that there's a black rubber gasket around the chamber there, and that's what that's there for. So a sealed chamber also provides you with a little more protection, you could say. You notice she's putting on the cap. We'll talk about biocontainment in a minute. But then also the chamber is sealed because of the need to do that for maintaining refrigerated centrifuge. So I would say these days the tendency is to move more and more towards refrigerated because we've making them smaller, higher performance, and probably not as much cost chain differential as it was years ago. But again, a ventilated is very much a viable option if for cost, space, and if you don't need it. And it says here, for example, working with blood, which is all done at room temperature. So I mentioned biocontainment. Let's come back to that because that has been becoming more and more important, as we well know, these last years. And one of the issues that we encountered as we went out and talked to our customers was that the old style of doing that was cumbersome. And the way we found that out it was pretty straightforward. You go into a lab, you'll notice that all the biocontainment lids and paraphernalia are in a drawer somewhere. They're not being used. So the idea is what's getting in the way of using them. And two things happened. One was, well, they're a little bit cumbersome to work with and clipping this. But the other one was we need something that's glove-friendly. We needed something that was not liable to be ripping a glove or something. And some of you may know, or maybe you do it, there's many who go out there in double glove. And the idea is, okay, if I tear the top one, then I still got the second one for protection. And so the idea here is you're going to see more and more of this where people are going to be putting together these, we call it glove-friendly, easy-to-use closure system. And we're seeing in the last few years, we first introduced this in our benchtop some years ago, we're seeing now that these things are not lost in drawers like used to be back in the old days. They're actually getting used, and that's the key. Because it's easy to use, and people understand how to snap it on, and aren't anxious about anything else about the use of it. It gets used because, of course, protection is key. And so that has been one of the exciting things in our business, that the biocontainment has come along strongly here in these last years. So another thing here to talk about, which is a little bit subtle, but some of you will know everything about this, and it's called acceleration and deceleration rates. You remember in the first picture I showed the motor drive down there. Well, absolutely, most of the customers are in a hurry, we know. Most of our users, they want to get the centrifuge started, they want to get up to speed, get in their 20, 30, 2-hour run, whatever it is, and get down, open up, and get their sample out. We recognize that. But there are some customers, blood bankers are a special one, but also people who are running gradient work, and especially sucrose gradients that are fairly gentle gradient. There is the need to make sure that the acceleration and deceleration don't mess up what you just did in the run. So on the way up, you don't want to disturb that gradient you created, and therefore your separation is doomed from the start. And then on the way down, once you put all that energy in and created a separation, you don't want to shake it up and then undo some, if not all, the work you did in the run. And so one of the things that we talk to a lot of our customers about is, first of all, are they in a situation where they need to be careful about their accels and decels, and we can help with that. And then the second part is, okay, but let's do some work. And this is you see a chart here. This is just out of some work that was done some years ago, and not meant to be read here, but you kind of see that there's some data taken here, and that's the idea. You can take some data, and you can identify what's the best accel curve or your decel brake setting, these type of things that give you the best result on the front and the back. And honestly, I would say probably 80 to 90% of that work is done on the decel, but I have seen some accel problems too, so we always ask both ways. Let's talk through that and make sure that you're getting the best possible result. I guess there have been cases, although they're rare, where you get no result, and that's obvious. But I think often people are sub-optimized. They're getting a result, they're living with it, not realizing if they would take a little bit of time, do a little bit of work up front, they could get a much better result. And the accel-decel curves help with that. Then there's productivity. I mentioned up front that there's been so much more being done in centrifuges today than maybe there were, I know there were years ago. And you see that chart there that shows the blue going up. It's just a simple math. The productivity of what we've been able to fit into a typical benchtop centrifuge, for example, is amazing. One of those is carbon fiber. One of the things I didn't spend a lot of time talking about when we went over that chart is that carbon fiber actually does something else. By being lighter weight, it presents less of an energy challenge to the centrifuge. And what does that mean? It means the centrifuge can be made smaller and lighter and still be safe running at high performance on the benchtop. Or put another way, you can keep the centrifuge the same size it used to be and do a whole lot more inside it. You can make a bigger chamber, a bigger rotor, and you get to higher speeds, all those things. So carbon fiber actually does something a little bit unexpected. It makes the centrifuges actually either at the same size do more or do what you used to do in a much smaller package. So that's kind of what this chart is showing, because over the years, we've gotten to where we've been able to move up to here. Let's give an example of how many 50 ml conical tubes, and who doesn't want to run more of those, it seems these days, all the way up to 40 from the original, whatever it was, 15, 20. And this has just been a direct evolution of taking advantage of the new designs and putting more in. So you get productivity just on the basis you can run more stuff, and if that's what you need to do, that's it. Here's another way to talk about it. If you think about it the other way, by being able to run more, you're actually using less energy per tube. It stands to reason, but that's the way we centrifuge people tend to think. We can only have so much energy we take out of the wall. We want to use it as wisely as possible, and here we are. By making a smaller, lighter rotor, going to a higher speed, maybe making a larger bucket that's in the same size centrifuge, you find you're doing a lot more. You're gaining a lot more efficiency of what power is you're pulling out of the wall and putting into the separation of the samples. So here the math just works out in this specific case to be a threefold increase in the energy used per tube. That kind of stuff can start to be meaningful, but it's certainly in the right direction these days. And of course, it's a direct result from what we're doing. So we're excited and happy to see that benefit coming out into our marketplace and into the labs around the country. Then there comes ease of use. I probably hear more about this than anything else. Of course, people have to be involved in, well, wait a minute, I have to I got a budget to work with. I had this old machine, now I need this other stuff. And we're talking a lot about applications. But at the end of the day, I spend a lot of time talking to the actual end user, and you'll hear a lot about, well, come on, can't you do better with how this works and that works? And here's a couple things that we have done, and you're actually going to see this in other places too, where we have made it easier to change rotors. It seems like a simple thing, but actually, if you go back, there's these tiny little knobs trying to tighten down. There's tools that are required and this type of thing. And people, as the picture in the bottom right show, are wearing these gloves, sometimes double gloves. We're not talking about, just doing this with the toxicity of your fingers. So what we've done is we brought out what we call something called auto lock, and they said there's some places on your screen probably to check for resources, and auto lock is one of those, and as well as the fiber light. That's actually the carbon fiber rotor name we use. So you can see those, and then you get to our website and get anything you want, I guess. But this auto lock has become a fairly positive thing all around in the industry, in the sense that you just push the button, off comes your rotor, and you set down your rotor, it's there. And I can tell you, I guess if you go back a ways, the two things I kept hearing back in the earlier days that were wrong, quote unquote, with centrifuges were the rotors are way too heavy. We know that. I'm a bit of a bigger guy, and when I'd go around the labs, people would say, "Could you help me move my rotors?" And we've addressed that very effectively, we think, with the carbon fiber. And then with the other one would be tightening my rotor down on the spindle. I mean, there's a concern that will it come off, will it do damage, will I lose my sample, and this type of thing. So we believe we've addressed that too with the auto lock. So those are a couple of key innovations that have just come along, pretty much recently. So what I like to mention to users when I'm talking to them is, if you haven't bought a centrifuge lately, you pretty much should think about what you want to do, because if you just say, well, I've got a centrifuge over here and it's old and it's dying and it sparks or whatever scary thing it does, and I just want another one like that, that's probably not a smart move. There's probably, as I said before, an ability to make a much wiser choice given the options that we have today in centrifugation. The phrase I like to say is, it's not the 80s and 90s anymore. It's 2014. There have been some serious advances in centrifugation these last years, and so if you haven't bought, especially a floor model, which is where I spend most of my time, most people buy more houses in their life than they buy floor model centrifuges. They last 20 or 30 years, and it was here before I got here is a phrase I hear, and all of that. So when it comes to these innovations, you just wouldn't know about them if you haven't bought lately. And that's why we like to get the word out that when you're choosing a new centrifuge, there's a lot more to think about, and for good reason, than perhaps there was 10, 15 years ago. The other one I mentioned earlier is the biocontainment, but this comes back to sample containment. We are concerned about, obviously, the user, but also the issue being, how about the sample? And so we have tried hard to put this to make this work both ways. So as we put the customer samples in our buckets and tubes, put the caps on, all that, the idea is to keep them in a format and in a way. Here, this would be a benchtop that you see in this picture, but even in a floor model, if there's a vacuum and these type of things being applied, that the sample is also safe in there. So make it easy to use these things, and then they will get used, and we can take advantage of that. That's what I have to speak about, but Trevor, I don't know if maybe you have some questions or other folks might have some comments.
Thanks, Dan. Yeah, I do have a few questions that have come in. And just a reminder to our viewers, if you have any questions, you can simply ask them by typing them in the query box that's located in the bottom left-hand side of your screen. So, Dan, the first question that I have concerns the carbon fiber rotors. You say that they're lightweight and they last longer, but how much lighter are they, and what kind of lifespan can you expect?
Yeah, I think I mentioned lighter. We use the phrase 50%. It kind of depends. 60% lighter, and then if it's a smaller rotor or something, the advantage might be a little bit different, maybe less than 50%, but that's a good rule of thumb when you're going into it. But you mentioned the other part, lightweight, and the other one, lifetime. Yeah, I probably didn't put enough emphasis on that the beauty of carbon fiber is also that since it's not stretching, it doesn't have really a fatigue curve. There's really no engineering end of life, which we do have in the metal rotors. So we put warranties and lifetimes on our metal rotors. Say an ultra rotor might have a 5-year life and then a 5-year warranty, excuse me, and a 10-year life. The carbon fiber rotors, we put a 15-year warranty on it, and we have no engineered end of life. So we don't ever come back to a carbon fiber user and say, you've had that carbon fiber rotor too long, it's worn out, you need to get another one. It's after 15 years, it's no longer under warranty, but it can be used ongoing. And it brings up another thing. They are repairable, so that if something were to go wrong with it, in the out years, instead of saying, well, I guess I can't use that anymore, like typically happens to a metal rotor, we can repair it and get it back into operation. So yeah, you can have it forever after that. And so that's kind of the issue with the long life of the carbon fibers.
Great, thank you. Now, you mentioned the stretch on the metal rotors. Does that affect the performance at all, or just the lifespan, or how does it affect the safety of the centrifuge?
Well, I wouldn't say affects the safety. I mean, obviously, we made a whole industry on metal rotors, right? I mean, that's how we got started, 50 years ago, whatever. I wasn't there then, I'll be quick to say. But no, it was all started with metal rotors. So we knew how to make safe centrifuges. We know how to do that. Contain them in case of a rotor disruption, we called it, that type of thing. The key is, though, as we've moved forward, is to the extent that you go to carbon fiber and you don't run the old, heavy, high-energy metal rotors, you can make a centrifuge that has more performance in it, is lighter weight, has larger chambers because you don't have to put so much armored plating in it. So basically what the carbon fiber does is not add to safety. What it allows you to do, so much because we were safe before, we still are, is that, as an industry, is that it allows you to do more in a centrifuge because it's kind of changed. We used to say take the physics handcuffs off because of the lightweight and low energy disruption that a carbon fiber rotor offers. So all that's kind of techy, but what it means to the end user is, you need to go looking what's available today because it's probably a whole lot more for your dollar than it was back 10, 15 years ago.
Great, thank you. Now, if you're shopping for a blood bank centrifuge, what sort of features should you be looking for in a centrifuge model?
Well, the first thing I would be looking for, from what I hear from my blood bank users and customers, is you want a workhorse. Blood bankers work these machines very hard, so you really definitely want to make sure that you have done your homework, you've talked to different users, and you know what centrifuges are going to last and do well in a tough environment. I would say the second thing you'd want to do is check for technical support as well, because typically a blood bank is a group of people who cannot really afford a lot of downtime. Sometimes researchers can have a centrifuge go down, they can borrow the one down the hall, or they can move an application maybe to another centrifuge beside it or something. But my blood banking customers, they need their centrifuges fixed, and they need them operating. So they do a lot of preventive maintenance and that type of thing. But then it gets into the features on the centrifuge. These days, given the larger blood bag sets that we have today, these quads and quints and filters and the fills going up to, heaven help us, 550 mLs from 500, you probably do want to look at who you're talking to about the centrifuge to see what the capability they have in the actual buckets themselves. Sometimes the customers refer to them as cups. Make sure you know that centrifuge is capable of spinning the large bag sets you're going to be wanting to do. That's one. And another thing that we have brought forward that we really like to talk to customers about is reproducibility, because let's presume you have all those basics I just described covered. The next thing you're going to find, and this is what I run into a lot, is a blood banker calling us up and saying, something's wrong. I used to get all of this good, and all of a sudden on this run, I got this problem. I got bloody platelets. I got something else. Or I just pulled out 6 blood bags. One of them's funny, this type of thing. So, or 12 in the case of our larger capacity system. So what we do there is we actually put on our systems a technology, or I call it technology, but it's a feature called ACE, Accumulated Centrifugal Effect, ACE, kind of a cute acronym. And what that basically does is it keeps track of the run so that instead of timing out, say, at 10 minutes, it will adjust it. It might let it go 10 seconds more or take it 10 seconds less, depending on the run, on what's going on in the centrifuge, so that every run is extremely highly reproducible to the one before. Many of our blood bank customers have standardized on this, put it in their operating procedures. So anybody new looking into it, we like to talk to them about using ACE because it does give you that extra heavy dose of reproducibility run to run. And I'll just say quickly, the most obvious example of that is sometimes most of the time you're running a blood bank centrifuge full, 6 or 12 blood bags, but then you'll have either the end of the run or something will happen or somebody will come and you'll make a run with just 2 blood bags, the other extreme. And if you that's a much lighter rotor, it'll get to speed faster. And if you just say timing, you will spin that in a different format. The ACE will kick in that case, and it will end that run a little bit early, so the same exact centrifugal force was felt by those 2 lone bags as opposed to a full rotor, say, of 12 blood bags. So that's another thing I would look at. It's probably enough to start. Maybe there's other things too.
Great, thank you. Now, if you're working with a specific type of tube, how do you find the centrifuge that's going to work best for you?
Yeah, good question. That's actually a pretty common question I get. And what you get is the user's got a tube in their hand, and they're showing it to you. Say, I want to spin that. And, of course, getting a knowledgeable person, a salesperson or something who knows the product line well and can say, oh, yeah, here they are, and just run it off to you is probably a good place to go. You can go to the literature. We've tried at times, and I know others probably have too, where you provide like online tools or the like, where you can go and say, I have to use this example, a 50 ml conical tube. What centrifuges and rotors do you have that spin that? So that would be something that we make available. Now, sometimes people will hold up a tube and everyone's looking at it like, that's new or that's different. In that case, then what we do is we try to match that to some of these myriad of these adapters that I was mentioning earlier that we use in some of these centrifuges and find one to match that. And occasionally there'll be a new thing coming along and we'll need to go back and innovate and come up with a new adapter or something, and we'll do that too. I mean, that's not that common, but it does happen. People come up with it. I just mentioned at the beginning, their research is changing. To buy a centrifuge 10, 15 years ago when the research has changed so dramatically also is another reason to rethink, when it's time to get a new one. And one of those could easily be that they've got some new, filter-based tube system that, it just come out last year and it doesn't quite fit right in the centrifuge or the rotors and adapters we have, and either can we find a different one or can we adjust would be something that we encounter probably once or twice a year as well.
That's good. So there are options if you have an unusual vessel size that you're working with. Great.
Yeah, in fact, that's why that chart up front, it is interesting that, for us to sit back and say, here's what we need in terms of bottles and adapters and the like, we would only get, say, 80%. The rest of it is always done by being, interacting with our customers, having them say, this is what I'm doing, this is what I need. Now, at the same time, I'll quickly say for anybody listening that if this is in your interest, we'd be glad to hear from you. We also will want to encounter, well, how fast do you want to spin it? Because some of these things that want to get spun, the material itself, the plastic or whatever, may struggle to withstand the G-forces that are needed, in which case then we will need to support it in a special way, as you saw I mentioned in carbon fiber, to make sure that you can get the performance you need. I mean, just fitting a tube in is only half the story, and it may not be enough, anywhere near enough. Number one, put it in. Number two, be able to get the G-forces. And I'd say over the last 10, 15 years, that's been an issue with microplates. Microplates came along fine, no problem. I want to spin it. At first, they were very low Gs, and now there's all these applications, these higher Gs, and we've had to innovate and get these different support systems in place so that you can spin these microplates at faster and faster speeds while not, or higher Gs, while not doing damage to that, but getting a good separation. So it kind of, in that case, when we get into those situations, it's like a collaboration between us and the end user and the application they have.
Great, thank you. Are there any limitations in how fast you can spin the carbon fiber rotors?
Well, I'm sure there is. We haven't really found. We really haven't found it yet. Our limitation has been the centrifuges. The centrifuges were all designed back when metal was there, and what you see are the limitations of the metal centrifuges. Now, what happened was it's a catch-22. It's a feedback loop. The applications have stayed within what metal could do with the current motor technology of those days, motors and drive. So yeah, actually we can do more things with carbon fiber. What we have found is that, as I showed in that one slide where we've kind of tailored the carbon fiber to do things metal couldn't, we've also found that with the on the top end, which is the fastest in centrifuges in the ultras, we've found that a lot of people have been moving away from the really high-end DNA RNA work. I just had a customer 2 weeks ago who was doing it, so it's still out there. But they're moving more towards protein. So what they're looking to do is actually larger volumes at high speed, at very high speed, or very, very small volumes. And so what we've done is we've innovated some of the carbon fiber to do that because the metal wouldn't let us do it. And so it's not a case of having higher speed. It's a case of getting more volume to a high speed and being able to do that in a way that's safe and also gets the job done. So it's sort of an interesting discussion. The carbon fiber will let you do a lot more than you can do in metal, and yeah, I guess we could go even faster than we do if there's an application out there. But at this point, we think we've addressed the ones we know about, and that's always the point. We're always trying to get out there talking to customers, finding out new things that are happening, and see if we can apply it in a new way.
Great, thank you. Now, you mentioned that benchtop models are becoming, more robust, I guess, for sake of a better term. If you're trying to choose between a benchtop and floor model centrifuge, what sort of options are there out there?
Yeah, that's actually become more of a question. I think you go back, it was pretty obvious if you were, if you really needed the high performance and the large volumes, you automatically went to a floor model. I would say now, somebody who hasn't been in the market for a while, I would just start with that question. Gee, I'm going to be doing this. Can you tell me whether there's a benchtop option? And strangely enough, we also have benchtops, then we put like a cart under it, or a design of a cart. It's not really a cart. And so it actually turns out to be a floor-standing benchtop, but that just makes life interesting because some people want to do that. But I'd say basically two things. Number one, look into the capabilities first. Don't just presume, okay, this kind of, needing 6 liters or 4 liters always was a floor model thing. So needing 3 or 4 liters. And so, I got to buy a floor model. Actually, we can do up to 4 liters on the bench now. So, and it's really good G-forces. So, that might be it. The other thing, though, to ask, and this is where the fun factor in my mind comes in when dealing with customers who are looking to buy new. You can now, because of that, maybe think of it differently and say, what's more valuable to me, my bench space or my floor space? And when you do that, it gives you some options maybe you hadn't thought about. So sometimes people go with floors, like the one I mentioned, where you can put it has essentially it's a floor-standing bench top. Excuse me. They do that because the bench space is critical to them, and they don't want to use it up, but they still want that capability. So I think we're getting to a point where there's more and more options to the end user when they talk it through. But I would still say, if you, like I said in that earlier chart, if you really want high-end performance, super speed or ultra, or you want to go to 6 or liters and that, you're going to be driven towards a floor model. Other than that, you can probably look at benchtop for a lot of the applications that normally would have been done in a floor model before.
Great, thank you. Now, you mentioned those auto locks and biocontainment lids and that sort of thing, which are sort of ease of use things. How do those impact safety in the centrifuge, apart from people actually are using them rather than keeping them in drawers?
Yeah. Yeah, right. Actually, that is the biggest one that I hear from some of the folks I go around, the lab managers I talk to, is we're actually using them. I mean, that's a big deal. All of these things are tested. It used to be called Port and Down, so I keep saying that, but I think they've changed their name. There is an industry-wide group in the UK who does do independent testing of most everyone's products. And what we do is whenever we come out with something like a biocontainment lid or these type of things, we'll send it near the end of the development program. We'll send our near final versions or final versions to that group, and we'll have them test it, and then they get a certificate. And that's really strongly how we rely upon those results. So when we make a claim or able to say this thing's going to be something you can rely upon, we can. Having said that, that means that it's been cared for well, and most importantly, that means the O-ring. There's typically an O-ring in there. And so often when I'm going around the labs, I'll talk to people about, I probably at first don't even realize what I'm doing. I'm just looking at their hardware. But one of the first things I spy is, if I can, is the O-ring status of the O-ring. Because if it's not properly greased, not only will it not do its job, but it tends to then start cracking and breaking up. I know everyone's probably seen this if they've been around the lab. And that O-ring's not doing its job anymore, so it's a false insecurity. You close that lid, and it might feel right. It might feel like you're compressing an O-ring and all of that, because there is stuff in there. But if it's not a viable O-ring, it won't be doing its job in the case that it's needed. Now, a lot of our rotors we send with an extra little packet of O-rings just for that very purpose, but sometimes I find those in the drawer as well. So, and we provide those, for folks just to, if nothing else, just to make sure they're being good about it. It's not hard. You just have to train folks how to inspect and grease an O-ring. But again, all that hardware you see and all the ease to use won't mean a lot if that's not getting done. But if that's the case, if people have it in good repair and close it as it's designed to be, there's people all over the place using these things and safely and properly feeling secure in their use of the centrifuge. Absolutely.
Great, thank you. Now, you talked a little bit about servicing centrifuge there with the O-rings. What other service considerations do you need to look into when you're purchasing a centrifuge?
Well, yeah, I guess the general thing is you want to make sure, maybe even, know what's going to happen, and maybe service people are around all the time. Maybe if you know them, talk to them and make sure, they're available to you. And if it's a top-end centrifuge like an Ultra or even a Super Speed, you might want to put preventive maintenance on it or that type of thing. But let's start down in the benchtop for a second. I talked about greasing the O-rings. The thing you're going to want to do in a benchtop, and any swinging bucket rotor for that matter, is you're going to want to lubricate the trunnions. We had a case, it was just last week, I think, and a person called up. They were having a problem, and it was a blood bank. And what we found out is somebody had cleaned properly the rotor, but for some reason they had missed one of the trunnions, or I think it was. And so what had happened was one of the buckets wasn't swinging smoothly. The other 5 were. And so it was weird. When they didn't clean it, they were getting suboptimal performance, but they were living with it. When they started cleaning but didn't clean properly, now all of a sudden their separation was messed up because the rotor was slightly imbalanced. The obvious answer was clean them all, have them all properly greased. Now, one of the innovations we've had in the last few years, I'm sure this will be more and more, again, talk about having to ask what's new lately, is we've come out with some materials that don't need lubricating, some swing-out rotors. So I forget we have a name for it, but it's like a Teflon coating. But that type of thing is really excellent for that type of scenario where people don't properly maintain it. Then it's taken care of. So basically a benchtop is going to be pretty robust. You don't have to worry about servicing the motor drives. Years ago we used to have brushes in them. You had to change the brushes. That's long gone. There's some things like if the door has a spring opening, which many of them do now, gas spring opening. You got to watch that. If it's being used a lot, it might start to fade. The springs will fade, and that'll be an issue. And a quick service call would take care of that. If it's a refrigerated unit, that's the other one. You have to, make sure you're sensitive, you're getting the temperature change that you're expecting, getting cold when you want it to be cold. When you get into up into the floor models, though, especially the faster ones, that's when you've got to watch for, if you're managing the motor drive system, you want to watch, and this is true probably in every centrifuge, but more importantly in these, you want to watch that rubber boot that's down in the bottom of the chamber that seems to cuddle your drive. That thing's important. It is cuddling. It's holding anything that comes out of into the chamber, whether it's condensation or a spill, from getting down into the motor. And that's particularly important for top-end centrifuges, that you manage to reach in there almost every run if at all possible, and clean it out so that nothing gets down there and challenges those spots. And of course, also, if you see those rubber pieces are beginning to look frayed or in any way, it's certainly a case where a little bit of money now will save you a lot later if you'll have your service person come in, take a look at that, and maybe replace that protective boot on that. So those are some things. And if you've got a vacuumated centrifuge and a refrigerated one, you want to wipe the rubber gasket a good bit. Don't let that thing get sort of eaten up. They usually don't. It's the O-rings that go quicker if they're not properly done, but taken care of. But still watch that, because you are relying on that big piece of rubber around the top to help you either get a vacuum or hold your temperature. So that's important too. And, I mean, we could keep going with some of the things, but those are probably the key ones. But let me mention one, and just wrapping this question up. You mentioned the centrifuge. It's in our world, in the floor models for sure, it's the rotors. Folks will leave a rotor in chamber, which is fine, especially if you want to keep it cold in there. But what we have said for years is, especially if it is a metal rotor, to please take it out, rinse it out, and turn it over on some kind of absorbent towel, and let the water and any spill get out of it. Because sitting down on the bottom, they eat away in there and corrode. It is one of the pluses of carbon fiber that it's much less susceptible to that, and we're glad about that. We'll tell customers that, but we also say, please don't use that as a reason for bad behavior. It'll be more resistant to being mistreated, but why do that? Why not treat it right, and it'll even do that much more for you through the years. So we've been that when you talk about the rotors, that's where I probably have seen just as much abuse, if you will, as other places around the centrifuge.
Great, thank you. Well, as I look at the clock, I see our time is running down. But I'd like to thank you, Dan. It's been a really insightful conversation. I think I've learned more about centrifuges today than I have in the past 15 years. So with that, this brings us to the end of today's webinar. If you have any further questions, please consider reaching out to Dan directly. His contact information, as you can see, is available on the screen now. If we didn't get to your question, I will forward those to Dan, and he can respond to you directly. Just a reminder that today's webinar was recorded. You will receive an email notifying you when the on-demand video is available. And this concludes our product spotlight. I'd like to thank all our attendees for taking time out of their busy schedules to join us today. We hope you can join us for our next product spotlight, which focuses on how new technologies are transforming the way labs work today. This webinar will be occurring Wednesday, September 17th, from noon till 1 p.m. Eastern Daylight Time. Please visit www.labmanager.com for details. On behalf of Lab Manager, I'd like to thank Dan Hanle for his time and Thermo Fisher Scientific for sponsoring this product spotlight webinar. Thank you all, and have a great day.